Okay, topic 22, geometrical optic. We go to 22.1, spherical mirrors. 22.2, refraction at spherical surfaces. 22.3, thin lenses. So it's a short topic if you like. We are now on page 119. Spherical mirrors. At the start, that is the book you can refer to. Turn to page 119. Syllabus. What is the syllabus requirement? Use the relationship F equals to R over 2 for spherical mirrors. They didn't say derive lah. Okay, so I assume no derivation required lah. You know how to use this formula. Draw ray diagram to show the formation of images by concave mirrors and convex mirrors. Use the formula. So they didn't say about derivation lah. I think your reference book derive it lah for spherical mirrors. Okay, geometric optics is just a branch of physics which study the properties of light using ray model of light. That means we think of light just as a ray. A ray is just a line, a straight line. Light is assumed to move in a straight line. Right? Light move in straight lines, and the straight lines are called rays. Reflection, and the formation of images by mirrors and lenses can be explained. This knowledge enables the making of telescope, microscope, and binoculars. Right? That's the reason why we are studying lenses. This is your spherical mirrors. Spherical mirrors. These are your thin lenses. Right? The key term is thin lenses. Okay, let's go to spherical mirrors. This is your concave mirror. This is your convex mirror. Spherical mirror is part of silver-coated spherical surfaces. Right? This part is silver-coated, like mirror lah. This part is silver-coated. For concave mirror, the reflecting surface is on the interior surface of the sphere, right? Just like this is like a cave, if you like. If you draw a straight line, this is like a cave. Right? So that's concave. So this is interior. So that is your reflecting surface. Sorry. Whereas convex, the reflecting surface is on the exterior. This is the interior, that's the exterior. Remember, they are part of a circle or part of a sphere. So that's the reflecting surface of convex mirror. Right? You will probably see this type of thing on a corner of the road, right? Because you got a wide view, allow you to see your corner. Right? Center of curvature, C here, center of curvature, center of the sphere of which the mirror is part of. Okay, so that's your C. That's your C, different place. R, radius of curvature. That's your radius of curvature. So radius of curvature. Radius of sphere of which the mirror is a part. Pole, P. Just a point here. Right? On the principal axis. Just a point here on the mirror. Center of the mirror surface. Aperture. This is the whole thing called aperture. Right? The area. Say again.
Aperture.
Aperture. The surface area of the spherical mirror. Okay. It's just memory work, nothing much to teach you about this one. Let me just adjust the voice a bit. Right? Aperture is just the surface area, that's all. The surface area. This is two dimension, so you can see the surface. Okay, principal focus and focal length. Right? Focal length F. This is the focal length. Distance from pole, there's a pole, to the principal focus. That's your principal focus, F. That's your principal focus. Okay, a concave mirror is behind. Sorry, for a convex mirror is behind. For concave mirror is if you think of there is a curved surface, there's a sphere, the radius center of curvature is here, so the focus is here, CF. So that's your F. The important thing. Then principal focus, that's your F there. Principal focus, that's your F there. For convex mirror, this one, a point on the principal axis, that's your principal axis, where the ray parallel, this is a parallel, right? It's shown in one, but the rays are parallel to the principal axis, seem to diverge, right? This one seems to diverge from there, right? Comes here, reflected on the surface, that appears as if it's coming from that focus. Concave mirror, this is the one, right? Same, is a point on the principal axis where the rays parallel to the principal axis pass through after reflection. Right? That's a parallel rays, right? One of them. After reflection, it pass through the focus. Okay. Did you all do in SPM?
Yeah.
Then why they have it again? I can't understand.
Maybe we might have forgotten. That's why they put here back again.
They go into multiple lah. Okay, let's review some of the things. Plane mirror, right? There's your incident ray. There's your reflected ray. There's your normal, right? There's your angle of incident. There's your angle of reflection. We'll be using a lot of this idea. Why is it not responding? Right? There's your plane mirror. There's your concave mirror. Okay, relationship between R and F. Right? That's your parallel rays. After reflection, there's your concave mirror. It goes through the principal focus. There's a center of curvature, or center of the sphere, if you like. Light ray, very close and parallel to the principal axis. Remember, right? The diagram is a bit deceiving, but we are looking very close. That means where BP is very close to P. Right? Very close and parallel. These two rays are parallel. Right? Very close and parallel. That's a key assumption. So that height there, right, where we call D, is actually the same as BP. Right? Remember, it is very close, so the arc will look like a perpendicular line. Okay, BP is equal to your D. B is close to P, so BP equals to D. And that radius of curvature, that radius there, is very much greater than D. That's what it means by close. Right? We compare the radius of curvature. That's the radius of curvature. Right? And that radius of curvature will go through the normal, perpendicular to the spherical surface. So CB is the radius, R equals to R, radius of curvature, and you also pass through a normal. And then if you look at this, is the angle of incident. This is a plane surface there. So that's the reflected ray, that's the incident ray. So that incident ray, reflected ray. So if we call angle of incident theta, the angle of reflection is also theta. Right? These two are parallel. So these are alternate angle. This is also theta. Right? If we look at this triangle, then this is the exterior angle. Theta plus theta is 2 theta. If you look at triangle, this is not maybe not required in your syllabus, right? Because your syllabus didn't mention about derivation, but I thought I just show you that it can be derived. You just treat it as your information. Okay. BCP. BCP is triangle. BCP. Right? Tangent theta is just your BP over that one. That one is radius of curvature. Okay, remember, BP is very close to each other. That vertical line is basically on P, if you like. That's the reason why we use a tangent. That is your D. This is your R, or very close to R, if you like. D over R. And this triangle, BFP. Okay, BFP. So tangent to theta equals to D over that one. That one is F. FP is your F. Okay.
Sure.
Yep.
Actually, the theta and theta together, right? There's one up, one down, right? Correct.
There's one theta here, one theta here, one theta here.
Yeah, technically there are two theta. That means the maths thing, right? Two theta up and then two theta down, the zigzag method, right?
This is two theta, same thing. This is two theta. This is
Yeah.
two theta. So this is also
Yes.
parallel line. So this is also two theta, lor.
Yeah lah.
Alternate
Correct.
angle.
So same lah.
Whatever you want to use it. Then we use the expansion formula for trigonometry. Tangent to theta is 2 tangent theta, 1 minus tangent square theta. Right? Then replace this one with df. And then replace tangent theta here with d over r. Right? This one d over r square. Right? As I say, we use this approximation. R is very much greater than d. So if very much greater, that ratio d over r is very, very small. So it's very close to 0. Right? So that is 0. This is 1. Right? So that becomes 1. Okay?
So it's a 1 minute. I just want to see this.
It's in your book. It's in your book.
No, I don't get it. Wait, I'm just 1 minute.
Okay? Basically, we are just using that. R. R is very much greater than D. So if R very much greater than D, you can treat this as 0. Right? That's what we are saying. This is equals to 1, very close to 1. That's all.
Oh. No, the D equals to 2x D over RY.
D times 2 times. From
Oh,
here.
yeah.
From here.
Okay, okay. Okay. Tangent square theta.
Yeah, that is tangent theta. Tangent theta.
No, tangent to
Then
theta
1
y d over
minus
f.
tangent square theta. So you square this
okay,
one.
understood.
Square this one.
Okay, correct.
Okay.
Yeah, can go
So
proceed.
1 subtract this is very small. We can treat as equals to 1.
Yeah, because it's more than R is more than this one, so make it into 0 lah.
Yeah.
It's between 0 maximum
Then
1
rewrite
lah,
that.
but just
Right? This one is just 1. So we can neglect that. So we get this formula. Right? D and D can cancel off. So we get our answer.
yes.
R is equals
R
to 2F.
equals
Yep. What's the problem?
wait. 2 times 1 over R means 2 over R equals to F.
This one is 1. So we are left with this one, that's all, which is here. And D cancel off. Cross multiply, take R across, take F across.
Teacher, isn't it 2 over F?
Then got 2 over F. We take the F across up, take R up to the other side. So it becomes R equals 2F. No?
Oh, yeah. Okay, correct.
Okay,
Yeah.
okay, that's the key. Memorize that. R equals to 2F.
Yeah. Correct.
Okay, let's go to ray diagram for convex mirror. Right, here's your pole there, P. Right, doesn't matter you use capital R or small r, radius or curvature, it's the same thing. Just a symbol, that's all. Right, there's your object. So the first ray parallel, it's not in your book. Ray parallel to the principal axis appear to diverge from the focal point F after reflection. That's your focal point F. That's your center of curvature. Right? So parallel, number one, parallel to this axis, principal axis. Right? Appear to diverge from here. So you just draw a line here from the principal axis, a broken line. Broken line. And then from there you can draw your reflected ray. That's your reflected ray. Ray that directed to the center of curvature. Center of curvature is here. Right? So that directed to the center of curvature appear to be reflected back along the same path. Right? That one, the ray will go from here to C. Right? There is the line, you can draw that. Then you can draw your that ray. It won't go through C, right? But it will appear as if it's reflected from C. Right? And then the last one, you need three only. Any two can be used to trace your object. Ray which are directed to the principal focus. This one is parallel first. This one is directed to the principal focus. Focal point F is reflected parallel to the principal axis. Same thing, draw a broken line, right, from the object there to F. Then, as said, it appear, right? Appear to go to the focus. So you can now complete. That's number three. Draw this ray. After reflection, it go parallel. Okay. So the object, that's the object. The image is here. If you produce this one, the three lines should intersect here, right, behind the mirror. Okay with that so far?
1 minute. Okay. To diverge from. Teacher, diverge means coming out, right?
Yep.
So that means it's diverging from the F lah. The one, the ray parallel
This
to the
one,
principal axis, something
diverge
else.
from F.
Okay.
Diverge,
After the
appear as if it's
reflection.
coming from F. Let's call diverge.
Oh, that means it will hit the like parallel first, and then that one it come from F, and then it actually diverges lah.
Yeah, it's parallel, and appear
Yes.
to be deflected from F. Appear diverge from F. Whereas if you use this one, the one going to F first, after that it will be reflected parallel. If you take the one going to curvature, appear as if it's going to the curvature, then it's reflected backwards.
Okay, wait 1 minute. Number 2, ray that directed to the center of curvature appear to be reflected along the same path. But sir, how come the C is hitting towards the object? That one I don't get it.
It should be reflected back.
Okay.
Because that is where it goes. It must be reflected back.
From the object lah.
From the mirror.
From the mirror towards the object. Okay, yeah, that means reflected back. That means it never diverge or converge or anything, right?
Only diverge is this one.
Yeah.
Right? This one it reflected back. Appear as if it's reflected back. You can think it's diverge also. It's also diverge. It's going that way. As I didn't show you. It's just too confusing if you show you too many arrows. But it's supposed to be appear as if it's reflected from here. That's all.
ray which directed to the focal point F is refracted parallel to the principal axis. But teacher, the line where the object towards the focal point F is not parallel, teacher. The principal axis is like different line.
This is going towards the focus.
Yes.
After reflection, it go parallel to the axis, or parallel to this axis. Whereas this one is
You mean
parallel
it
first.
diverge,
Where got diverge? Just reflected only.
No, but the number one also, they diverge look like the same only.
The reflected only. I don't go and use the term. Simply use the term is just reflected only. This is diverge. Instead of going, number one is going, instead of going straight there, it diverge. It reflected that way.
Yes.
Diverge means it is instead of converging to the point there, right? Instead of converging to the point, it just go the other way. That's called diverge. Okay.
Oh, okay.
Already in the STPM already, and you still got problem.
I forgot, teacher. They don't 2 years ago, one left, of course. Yeah, okay, can continue, I guess.
Okay. Image formation in convex mirror. Right, that's your object. Right, that's the ray parallel to the principal axis, the axis there. Right, and then we say it diverge. It is diverge from that point there, diverge from the focus. And then if it's going towards a center of curvature, it will be reflected back. Right? So I is the image, is virtual. Right? It's behind the mirror, virtual. Diminish, that means smaller. Form behind the mirror, that's what it means by virtual. Right? You cannot get on the screen. So it doesn't matter where you put the object here. For convex mirror, always the same. Virtual, upright, diminish, and then form behind the mirror. Right? Only one only for convex mirror. One thing to remember for the image. Convex mirror has a wide field of vision. You can see a wide range of vision there, a wide field of vision compared to plane mirror. Right? That's the reason why we use it on the corner of the road or in your side. Right? Application, rear mirror in your car, side mirrors of car, that's your side mirror. Right? Sharp corners of road. Yeah, and have that so a person can see whether a car is coming or not. Okay. It's all in your book, not all taken from the book. Any comment?
Just 1 minute, sir. Virtual means that means basically form behind the mirror is like you cannot see one, obviously.
Which means it cannot be captured on the screen.
Yeah. I mean, which
Right?
means it's behind lah.
It's behind. For mirror, it's behind.
The mirror. Diminish means small, right?
Yeah, diminish means smaller, smaller compared to the object. Upright, see, it means it's vertical, vertically upward like that, not inverted.
No, that means the image has to be between the P and F lah, so not the F and C.
Image just behind the mirror, that's all. So precisely
No,
where
I mean the
depend,
position.
precisely where if we have to calculate it out, right? You have to know the object distance, then you can say whether it's here or whether it's between here. Right? Usually it is less than U. Right? That V is less than U. That's all we know. From the you can get it from the ray diagram.
If V is more than U, then you put at the C side or something lah, right?
This one only. Your V is always less than U. That's why we call it diminished.
I see.
Always smaller than the object. Okay.
So wider field of vision compared to the plane mirror. Okay, can. So far.
Okay. Now let's go to concave mirror. Right? Ray diagram. Just repeating. Object. First ray parallel to the axis. And after that, after reflection, it must go through the focus. Let's go through the focus. There.
Oh.
And ray going through the curvature, radius of center of curvature. Right? That's number 2. Reflector backwards. Right? Reflector on the same line. I didn't draw it because it's almost the same thing.
And parallel.
And the next one is going through the focus. Right? Number 3,
And
going through the focus.
parallel.
After that, after reflection, it goes parallel. That's all. So the three rays should intersect, and that is your image. Okay or not?
Okay, so far okay.
Okay, if we put that's your F, that's your C. So remember, this is F. This is 2F. Right? CP is 2F. So anywhere here is U is greater than 2F. Right? That means the object distance is greater than 2F. That's the object. That's the first ray. Right? So it will be reflected towards F. After reflection, it goes through F. That's your first ray. Second ray, it goes to center of curvature. After that, it reflected back. So 2 rays enough already. Right? That's your object. That's your image, sorry.
You don't need to do the third one. So go through the
Don't need
focus
already.
and the parallel.
Third one is just a waste of time, but you can do it as a check if you want to. Any 2 rays satisfying the condition can be used to locate the image. Right? 2 rays enough. So the image you can see, right? There's your 2F, between F and 2F. Right? Between F and 2F. Characteristic, real, inverted, diminished. Right? Real means you can capture it on a screen. It can be formed on a screen. Virtual means you cannot form it on a screen. Real image can be formed on screen. Screen is just a piece of white paper. Okay.
Teacher, the 2F is which one?
There's a 2F, CP.
From where to? Oh, C to P is 2F lah.
CP is 2F.
Okay, okay. CP is 2F. All right.
Okay.
Okay. Wait.
Okay.
Okay, the words. I just want to see the words. Okay, go
in your
down.
book. In your book. Nothing much about that.
Real inverted diminished real image can be formed on the screen. Yeah, lah, this one concave, but convex will not be real image, right?
Convex is only one only. Concave means got a lot of different position you can put it. So the next one
convex means there's no real lah.
Next one you want to put it as C, center of curvature.
Okay. All right.
Right? Your object distance is now at the center of curvature. Same thing. First ray parallel. On reflection will go through the focus. And the one going to radius through the focus. After reflection will go parallel.
Oh, you need the third one.
Right? So you don't need a third one.
Yeah, no need.
So U is the object distance. V is the image distance. So image is at 2F. Right? Image distance is at 2F. Same. Right? Same. U equals to V in this case. Characteristic of image, real. Inverted, same size as object. Used as overhead projector. Okay. Anything that is not clear?
Yeah. Really inverted same size as outline. Correct. So using overhead projector means what?
Just remember it as well. Using overhead projector, that's your overhead projector. There's a concave mirror.
So anytime is U equals to
So
2F,
this
you
one,
remember
this
it's
one is your
overhead lah.
projector lens. There's a converging lens or convex lens here. This one. That mirror, that plane mirror is just to change the direction, that's all. Okay. Your concave mirror is here. To gather all the light and reflected it back. Okay.
Okay.
Okay, now your object is between 2F, that is CP, right? And F, so it's here, anywhere between C and F. Same, parallel, after reflection, on reflection of the surface, will go to the focus. And you can use radius of curvature. After that, reflected backwards there. So that is your image. Right? You can see the image is position of image. Image distance is more than 2F. Characteristic real, inverted, magnify. Okay, magnify.
Teacher, all the while that you, that means the second one will always pass through C lah, right?
The second one will always pass through C.
Okay, then up one is O. No. The original point is it O, and then get this. Okay. Oh, the intersection like it's a dim. It's an inverted
Yeah,
one
where the
lah.
cut, there
Real
is
and
your
inverted.
where the cut, there is your image.
Isn't it the same size?
So are you talking about same type?
No, size. The original one, the object and
Yeah,
the
it's on the
image.
same side. It's on the same side.
No,
Same
the
size,
size.
the
The
object.
size is the same, right?
But it's inverted, that's all.
Yeah, you put that magnified, sir.
Yeah, it's magnified. You can see from here yourself. Right? It's longer than this one. The image.
Oh. Okay.
Right? This one, object is less than F. There's your F. So object is anywhere here. Right? Less than F. Same. Right? Parallel. After that, reflection will go through the focus. Right? Then you have to produce it backwards. Because if you don't, then you won't get any image here. The image is not here. Right? The one going through the focus, same thing. After reflection, will go through curvature. So you have to draw the line, right? Produce it backwards to get the image. There's the image here.
Inverted.
No more inverted.
Magnified, virtual.
Behind the mirror. Position of image is behind the mirror. Characteristic of image, virtual.
Yes.
Upright. Magnified.
Yeah, I understand this, teacher.
Okay, so you can use this for shaving mirror. Makeup mirror. You want to magnify your face, or shaving mirror, magnify your whatever and to shave. Or dentist also, they need this type of mirror to see your teeth inside, to magnify the position of the teeth, so they can see whether got any cavity. Okay, Virtual means image cannot be formed on screen. Okay, Okay, object at focal point. There, then draw parallel. Then after that, reflected. After reflection, we'll go through the focus. F. And the other one, it will usually be, the image is not on the same side. It's usually on the other side. That's why we have a broken line there. Then the next ray is from the center of curvature. Reflected backwards there to the center of curvature after reflection. And produce backwards. So these two rays are parallel. Position of image is at infinity. Virtual, upright, and magnified. Used in torchlight and car spotlight. Okay. Anything not clear?
Just 1 minute, sir. No, sir, there's too many now. So not to say confused, there is like too many I need to analyze later and then we experiment.
It's not a matter of
I mean, I can understand, but then
you must do the homework. It can only teach you. If you don't do your homework, you'll forget about it. We are just applying the ray diagram. That's all. How to draw the ray diagram. That's all. So you have to go and learn yourself. Go and draw yourself.
Okay.
Right? Virtual image cannot be formed on the screen. It's always upright. Real image can be formed on the screen. It's always inverted. Right? This is for mirror, curved spherical mirror. Okay, equation of curved mirror. Okay, if it's concave, U and V and F are positive. Right? As long as it's all here, U and V and F are positive. Whereas for convex mirror, before you can use this formula, you must know that, right? If your V is here, virtual, right? It's negative. If it's a virtual image, also negative. Right? So basically your radius of curvature will also be negative. That's why your focal length is negative. Okay. Then no, that one is not in your book. Magnification is height of image over height of object, or V over U. Okay. Memory work, nothing much. Then know how to use the formula. Right? Or your book say, look at this side where the ray is coming from. Right? It's concave, call it positive. U and V is positive. But if the image is here, that is virtual, it becomes negative. Same as here, that's the ray. Right? C is opposite to that. That's why your F and your V are negative, virtual. Right? It's on not the same side as your object or the curve. Right? That's a C. That's your object. So that your F is negative, your V is also negative. Okay.
Go back, sir. Sorry. Previous page only. Okay. The real is positive, concave, and convex. Teacher, can you tell me which one is the F and which one is the V? I'm confused now.
This is your F here.
Okay.
That's your F here.
Yes.
So as long as your F is on the same side as the object, it's positive. This one, your F is on the opposite side of the object, so it's negative if you like.
Oh,
So V is
okay.
negative.
That means it has to be the object lah. It's connected to the object, that's why it's negative lah.
Yeah, you
because
refer
on the other
object
side,
because that's where the ray is coming from. You can look where the ray is coming from. So it's behind, then V is negative. Right? V is same size as the object, so that's why your V is positive here.
Okay.
Okay. Your worksheet, you should be able to try your 1 to 7. So let's
Okay.
try your checkpoint. I'm not going to carry on anymore because I think you won't do your homework. You won't learn anything. So that's the reason why I go to checkpoint. Go and do it now.
So 10 minutes, no 5 minutes.
You can try. Whatever you don't know, you ask. I will show you. No point, as I said, no point in going carry on new topic. You will get lost as well because you never do your homework.
No, so stop the Zoom or what, teacher, then join back later. Which one?
A ray of light move towards convex mirror parallel to the principal axis as shown in figure 1. Calculate the value of x.
I can't see your slide.
Can't see my slide. Why?
No,
It's wrong.
suddenly just showing me this try worksheet number 1.
You are not
this one,
supposed to
only
see
that
my slide. You're supposed to see your book. Don't tell me you're lazy again. You're supposed to work with your book. Not look at my slide and show me that you have not bring your book again. How are you going to progress? You tell me. Your discipline is very poor. Yeah, what's the value of x? Why take so long? Why take so long? Why take so long? Yep.
Teacher, which question?
Number 1, checkpoint. 22.1. What are you doing? We are going to do checkpoint 22.1, 22.2, 22.3. Right? You are supposed to be able to read the ray diagram.
X equals to 18.
Don't know what you are doing now. Whether you are paying attention in class or not.
X equals to 18.
What's your value for x?
18. 18.
Radius of curvature. You must know that K is the focal point.
Yeah.
And C is the center of curvature. And then X equals to 2F. 2 times 9 is 18 cm. Okay, good. Number 2. Figure 2 shows a light rays, which are very close and parallel to the principal axis. The light rays are reflected from the mirror and converge to a point F, a distance 3 meters in front of the curved mirror. What is the focal length? Yeah, should be able to tell me what is the focal length?
The focal length.
Yeah, why it take so long?
1.5.
F is your focal point.
1.5. 1.5.
Why 1.5?
3 divided 2.
Why divided by 2? This is not the radius. That is your focal length. This is your focal length. This is your focal length. FP. FP. F is your principal focus or focal point. So you
it's
should be able
3.
to
It's
read
3.
straight away. What is the value of focal length?
It's 3.
3 meter. F is the principal focus or focal point. So your F focal length is F equals 3 meter. What is the radius of curvature?
1.5
What 1.5?
meter.
Yeah?
1.5 meter. That's the answer.
No. You're not paying attention in class. We just did that in question 1. It's just getting you to use this formula, that's all. X equals to 2F and know how to read the ray diagram. The radius of curvature equals to 2F.
6.
2 times 3, 6 meter. The arc length KP give the angle of incident 45 degree. Okay, find the arc length KP. Yeah, this one is your math problem already, not your physics problem.
I don't understand the question.
They give you this is the arc, this is the angle. Then go and calculate this arc length, KP. K is supposed to be here, not up there. K is supposed to be here. They want you to find the arc length. Yeah?
Oh, 1 minute.
Why take so long?
Yeah,
Just compare only. Nothing
6.
much.
The 6. The answer is 6.
How to calculate it? I know you can check your answer from the back of the book. I know how to
Hey, I
calculate
didn't check the answer from the back. Okay,
Then how
tangent
do you get it?
45.
How to
Tangent
get it?
45. Tangent 45 equals to
Tangent
KP over
45.
6.
You can't use that. You have to use the circle. 45 over 360 is KP over 2 pi r. R is the radius. Right? Compare the angle. That angle compared to the arc there. 360 compared to the circumference. This is circumference. And from there, calculate. No tangent here. Okay? This is your math problem, nothing about physics. We just try to get you to use your math as all. What's the problem? What's the problem? I just take 45, compare with the total angle is 360.
Yeah.
And then 45 is this arc, right? K is here, not K there. K is here. KP is here. Compare to circumference. Circumference is 2 pi r. That's all.
2 pi r is the entire
Circumference.
KL, right? Sir?
Circumference.
What is circumference?
Circumference, I don't know. I must send me back to Form 1 already. Yeah. This is the perimeter of the circle. The circle. Circumference of the circle. The external. That
Say
surface
your
area.
mouse not moving.
That length there. Length of the circle. Circumference, the length of the whole circle. That's circumference.
Okay.
Okay. Okay, let's go to the next one. 22.2. You have to use your graph paper. Got graph paper or not? Sketch. If not, no graph paper, sketch. Get on your paper. And then show me the answer. Right? Can show me the answer after you have completed. Make sure you draw, draw and then show me. Okay, that's your 1A.
I thought you were going to a different question just now.
I didn't record it down. That's why I'm recording it down now.
Okay.
You just did it and then you tell me 110. I'm worried for
2
you,
times
Sweeney.
55 lah.
I'm worried for you. We just learn in class and then keep on stressing with you. R equals to 2F and you still give me F equals to R over 2. Right? Yeah, you got it wrongly already. Anyway, try the next one. B, an incomplete ray diagram with scale 1 cm to 5 cm is represented in figure 1 as shown in the above. Why is it possible to represent the concave mirror as a straight line? Yep. The first one you just divide by 2. Radius of curvature divided by 2. So it's 27.5, not 110. Yeah? Why we represent the concave mirror as just a straight line when we draw? Not paying attention in class. That radius of curvature is very large. So that one is very small. So it looks like a curve. Instead of look like a curve, it's actually look like a straight line. Anyway, complete the diagram. Complete the diagram. do the part 2. Complete the ray diagram and state the Ken, you get the answer? Can or not? Can or not? Can or not? The rays are close to the axis. The region where the reflection occurs is very close to the axis of the mirror. The mirror can approximate to a plane mirror, right? Because the arc is very small compared to the radius. Okay, should be able to get the answer. That is roughly the answer. Ken?
I give up, Chai.
What is the problem?
I give up.
Why you give up so easily? What is the problem?
Looks
Yeah.
hard.
You don't put in the effort, you say it's too hard. I just go over with you the problem. What is the problem? First ray, right? The first part is just memorize a formula only. We are starting from there. We have been using this formula. Radius over 2. 55 divided by 2 is 27.5. Then we use a straight line because this arc is very small compared to the radius of curvature, and the ray are very close to the axis. So basically, this is a straight line. That's the reason why we are using a straight line. And the ray parallel to the axis. After that, it goes to the principal focus. Up on reflection, it goes to the principal focus. That's all. Then the next ray going to the principal focus. After reflection, it go parallel. That's all. So where they cut or where they intersect, you get your image there. There's your image there. Then you can see that the image is smaller, inverted and diminished. Okay. Yep. What is the problem? What is the problem? Cannot. What is the problem? Okay, if not, let's go. If you are okay, let's go to the next one.
No, wait first.
You're not putting the effort to study. That's the problem with you. That's why you're not concentrating. Don't know what you're doing today. Take a short nap before you come for class. Yep. What's the problem? Anything not clear? Yeah. What's the problem? What's the problem? Which part is not clear to you?
Wait, teacher, the image you put there, isn't it wrong? So it's not the intersect one.
Image is here. What's wrong with the image?
No, it has to intersect two. In this case, isn't it the F?
No. What should be F? F is the focal point.
Yeah, but it intersected. Oh.
Intersect here. Not there. Not there. Intersect here.
Intersect where?
Where the final ray intersect. Don't look at here. Don't look at here. Here. Over here. Don't know what happened with you. This one you have done in your STPM. Now you are repeating the same thing and you still cannot solve it.
I forgot, teacher.
Forgot, even if I teach you, you should come back to you very fast. We just gone through very slowly with you the whole thing.
My memory not so good anyway.
Okay, now what's the problem? Don't focus on this one. This is part of construction. Focus on the final where they cut there. Where the two rays cut finally. Here. Not here. Yep. Can?
And
Okay. 22.3. Point S is 25 cm from a convex mirror of radius 60 cm. Determine the position of the image and say if the image is real or virtual. Take a picture of it. 25 cm. R is 60. Right? This is a convex mirror. So you want to put a negative sign, go ahead. So your F will be negative. You have that must be negative. You got a convex mirror. Then determine the position. Use the formula. 1 over F equals 1 over U plus 1 over V. Put in your value. Right? Take 1 over U to the other side. So 1 over F is 1 over minus 30. 1 over U, take to the other side, becomes minus 25. And the others is just calculator work. Calculate your V. Yeah? So you got negative sign means the image is virtual. Can? What? Any problem? Any problem? Any problem? Yep. What is the problem? Which part not clear?
wait, so it's negative 25, Archer.
Negative 13.6 means it's virtual.
No. The why the U they put there positive 25, but then in the calculation you put there negative.
When you write the answer, you have to explain why you get a negative sign. This 13.6.
No, I'm talking about negative 1 over 25.
I take this over. This 1 over 25 to take over to the other side, becomes negative. Yeah. This 1 over 25. I take to the other side, it becomes minus 21 over 25. F is negative. That's why I get negative here. Yep. What's the problem? Okay now. What is not clear? Yes, yes, yes. Tell me what is your problem.
Nothing problem.
We are just using the formula, that's all. If you understand, then you should be able to solve question 2 then. Okay, try question 2 then. This one. The figure shows a concave mirror with radius of curvature 40 cm. The image is from 10 cm in front of the mirror. State the distance of the object from the mirror and its position relation to the mirror. Okay, what's your answer? Can just using the formula, that's all. If you want, draw a diagram so you know what's happening. You picture yourself.
No, I don't understand what's happening.
You are told that the radius of curvature is 40 cm. So far, you're not concentrating. I can be honest with you. Formula also cannot remember. R equals to 2F also cannot remember. Right? So the radius is given you. You should know the focal length. Right? Radius is 40 cm. That's the mirror. So focal length is half that radius. So it's 20 cm. Then this one is less. The image is less than image. The image is from 10 cm in front of the mirror. So write down V equals 10 cm. State the distance of the object from the mirror and position in relation to the mirror. Use the formula, that's all. Right? Take 1 over V across there. So 1 over F, put in your value. F is 1 over 20 minus V is 10 cm. And subtract. You get minus 20. So minus means it's a virtual image. Right? So we should be able to interpret image is 20 cm behind the mirror. Okay? That means it's not here. It's here, behind the mirror. Okay now, okay now. You are going to struggle through this semester again, this term. You to put effort to learn, to concentrate.
So it's hard, like I can't even understand anything.
What cannot understand? This is just revising with you what you have studied before. It's not something new. You are going to struggle, that's why I say. If what you have learned in SPM you still forgotten, and I go over with you slowly and you still cannot do it, then I don't know what to do already. Wait, which part you don't understand?
Whenever doing question time, the term looks complicated.
Yeah, which part you don't understand? Yeah, which part you don't understand? First part, read the question. Write down what is given you. You want to find U. R is 40 cm. So focal length is just half of this one. That's why we do 20 cm. V is given you. Put in the formula, that's all. And subtract, you get negative. Negative means it's not on this side. It's behind the mirror, that's all. That's all know how to interpret, that's all. Yep. What's the problem? What's the problem? Yeah, talk to me, what's the problem? Yeah, Srini, what's the problem? Talk to me. Don't keep quiet. Which part you don't understand? Okay, let's go and do number 3. You want to respond to me. We are running out of time already, 5 more minutes. As a position object reflected in a concave mirror of 0.5 focal length is varied, position of image varies. Plot the image distance as a function of object distance, letting the object change from 0 to infinity. Right? So to do that, you have to go to the formula. Okay, so you want 1 over v against 1 over u. So take 1 over u to the other side. And then right? Common denominator is fu. So u minus f. Then put in your value. The position of the object reflected in the mirror is 0.5. Focal length is given you 0.5. Right? So I'm just inverted it, that's all. Take the v across, take u minus f down, take f times u up. So f I'm using 0.5, so 0.5 u. So u minus 0.5. Then I can plot the graph. U equals 0.5. Then v equals to infinity. U equals 0. U equals 0. V equals to 0 also. Or u greater than 0.5. U greater than 0.5. Okay, your v decreases. So that's how your graph should look like. Right? At this part, where is 0.5? This is 0.5 here. Goes to infinity. Then it's 0 here. So it's a curve here. And then it's greater than 0.5. V decreases. That's how it looks like. Okay. If no question, I will stop here. I'll see you next Friday. Make sure you have a rest first before you come for class. If not, you're wasting your parents' money. Yep, Srini, what is the problem? Can or not? Can or not? What is the problem? Yep. Talk to me. What is the problem? Which part is not clear? Yes, Srini, what is the problem? Okay, our time is running up. If you don't want to respond to me, we will stop soon. You better tell me what is the problem. Yeah, Srini, what's the problem? Anything not clear? Okay, if not, don't want to respond to me, I'll stop here. This is your homework for mirror. You can try the question out. As I say, you want to improve, you have to learn to understand it, and you have to try the question. There's no, you don't put the effort, you will see more and more stars. Right? You, as you like to say, you are frightened of physics. Okay? I teach you how to work through all the questions. That's the reason why I can understand the thing. But if you don't put in the effort, you're not going to make it this semester. So, okay, I'll stop here. Anything else you want to talk to me about?
No, sir.
Okay, I'll stop here then. Make sure you do your homework. Right? These are your homework for mirror. If you're going to master it, you have to try yourself. I cannot learn from you. I cannot give you the answer. You have to learn it yourself. Because I have to do it every day also. Work through the question, each question. Okay, I will stop here. I'll see you next Friday.
See you next Friday, sir.